Okay, so what we said in the last segment is that in order to get our carbon compounds to mix with water, we have to add polarity. So that means we need these elements on the upper right-hand corner of the periodic table, typically oxygen, nitrogen, sulfur to a lesser extent, halogens, yes, but they are problematic. So to make this visual, we have our carbon compounds, and we named our alkanes, alkenes, alkynes, and benzene. And now we need to add what we call functional groups. Okay, functional groups. And we have a list of them. There are a lot of them. It's just the way it goes. Okay, so there should be something on Blackboard that shows you functional groups. Okay, for the purposes of this hopefully last segment, I'm going to introduce what some of these are, and then I'm going to show you for your next course where you're going to see some of these. Okay, alcohols. Alcohols are an OH attached to what we call an R group. And the R group means you have to at least have a carbon. So for example, if your R group is an H, that's water and that's not an alcohol. But your simplest alcohol has one carbon. Okay? And your book gives you a bunch of alcohols. So for example, this is an alcohol. That's an alcohol. This is not. This is something different. This is an alcohol. This is something different. This is an alcohol. This is an alcohol. Okay? So what you want to be able to do is to see an OH attached to a carbon, and that by definition is an alcohol. An ether has an oxygen in the middle that's flanked on both sides by a carbon. It has to be a carbon because if this is a hydrogen, it's not an ether anymore, it's an alcohol. So your simplest ether is going to look like this. This is the oxygen sandwiched by carbons. You can have oxygens buried in a ring, and in fact you see this structure a lot when you look at carbohydrates. Okay, you can have your R groups be the same or different. Okay, here's your ether. There's one carbon, there's two carbons. Okay, aldehydes. Aldehydes have this structure. Okay, so this is C double bonded to an O, not C bonded to an O bonded to an H. Okay, so since there's a carbon there already, your simplest one can be this one. And many people are familiar with this particular aldehyde. This is formaldehyde. And this is a substance that you use to embalm things. Okay, so not all carbon compounds is good for you. By the way, if you drink this methanol, this is methanol. If you drink this, hopefully you will live. But at the very least, you will probably go blind because this will oxidize in the body to that. And that's why you never drink this kind of alcohol. There's a narrow range of alcohol that's quote-unquote consumable. Okay, carboxylic acid looks very similar to the aldehyde, except that it's got an additional oxygen here. Okay, so what you're seeing in your book, this is a carboxylic acid. This is a carboxylic acid. This is just the collapsed structure of that. Okay? Nope, that's my light source in my house. Okay? Here's a carboxylic acid. Okay? And so forth. All right? Again, because you already have a carbon here on your carboxylic acid, your simplest one is this structure. And in case you care, if this is kind of gnarly formaldehyde, you might expect this to be kind of gnarly, and indeed it is. This is called formic acid, and this is what you get injected with if you are stung by a bee, and that's why it hurts. In case you care, a 2-carbon carboxylic acid is acetic acid, this one, and that's what you taste when you taste vinegar. And in case you care, 2-carbon ethanol, which is consumable, will oxidize into acetic acid, which is what we would call vinegar, which is why you have red and white wine vinegar, or why you have some wines that taste terrible. It's because they've oxidized from this to that, just in case you care. Okay. Ketones. Have this structure with 2 carbons on either side. Your simplest one is this one. This is called acetone, in case anybody cares. You use that for nail polish remover or paint thinner. Okay? You can have all kinds of ketones. You can have them buried in a ring if you wish. You've got tons of opportunities. Okay? Esters. This is your functional group, and you have to have a carbon on either side. If this is a hydrogen, you don't have an ester, you have a carboxylic acid. So frequently you'll see an ester, for example, buried in a ring. Okay, there's the ester functional group, that's a carbon, so that makes that an ester. Okay, now we have just a couple more, and then we're going to wrap this up with where do you see this in the world around you? Why do you care about any of this? And why am I presenting this to you at the end of the semester when you just want to be done? Okay, amine. AM means nitrogen, just like ammonia or ammonium. So amines have this basic structure. Remember, we have a lone pair here. As long as one of these is a carbon, then life is good. You have an amine. If these are all hydrogens, you have ammonia. Okay, so something like this is an amine. Something like this is an amine. You see lots and lots and lots of structures like this, particularly when you look at nucleic acids and what we call nitrogenous bases. Amides are very similar. Okay, so here's the amide functional group, and as long as we've got a couple carbons on there, they can be the same, they can be different. We have what we call an amide. So an example would be that. I mean, I can put all kinds of things. And by the way, I can put multiple functional groups on these things. Okay, so here's my amide, here's my amine, here's my alcohol. Okay, and then last for this segment is what I'm going to call a thiol, and thiols are easy because it's anything with a sulfur. Okay, so as long as you have a sulfur, you have a thiol. Okay, now let me give you some examples of where you might expect to see some of these in the world around you. Okay, so a structure like this would be something you would see readily in a biochemistry class, and you're like, what the heck does that mean? That looks like a bunch of lines. Well, any place where there's a line means we have a carbon. Carbon, 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 carbon. Okay, and what you'll learn about these structures, you'll learn more about these structures in biochemistry. Okay, nonetheless, whether you're glucose, fructose, or mannose, these are all alcohols. Okay, alcohols, lots of them. Okay, so this is telling you that there's something about alcohols and carbohydrates. Carbohydrates have alcohol functional groups. This structure here is an aldehyde. This structure here is a ketone because that's a carbon and it's bound to a carbon on either side. This is a carbon with a double bond hydrogen bonded to this carbon thing. So these are aldehydes, this one is a ketone. So there's a relationship between these two carbohydrates being aldehydes and this one being a ketone. And these are what we call our isomers of each other, and these isomerize going back and forth.